Hello everyone. Today we are visiting a topic called metadata-driven pipelines, and we're going to take it from a simplified approach to better understand what it's about. So in a metadata-driven setup, we typically have a watermark table, and that is a table that contains some information about the pipeline executions. And then we have typically other tables, one that symbolizes the data we are going to ingest from, and one that we are going to sync it into. So let's imagine that we have a data engineer. He starts by creating a watermark table. Then in this table, he specifies which source table to load and specifies the date he's going to load from. In this sample, he specifies that he's going to load from 1901 to current date time. Then the data engineer creates a destination table to host the source data at the data warehouse site. At 1 p.m., a new record is being inserted into the source table. At 1:30, the data engineer starts the pipeline. The pipeline retrieves the metadata from the watermark table, and then it determines which records to load from this source table. In this example, it's loading every row with a last update date beyond 1901. Then it takes all the records and save it into our destination table. After the pipeline execution has successfully finished, we are updating the watermark table with the current time of day. And then we are ready for the next batch ingestion. At 2 o'clock, the system is getting a new row, and later at 3, the source system is getting another row. The data engineer then decides to run the pipeline again at 4. Current status is the source system has 3 rows, and the table in our data warehouse only have 1 row. The pipeline then goes again to the watermark table and retrieves the last load date time. It then determines to load all records with a last update date beyond 1:30, and then syncs the 2 records into the destination table. After that, the pipeline again updates the watermark table with the current date time. And on this goes in an endless loop. The pipeline always goes to the watermark table to retrieve the last load date time, and so it retrieves the data from the source and syncs it into the destination and updates the watermark table. This is scalable because we only need to make one generic pipeline that only swaps the parameters like table name and last load date time to determine which table to load from and how much. We can even make this solution even more scalable by adding additional columns to our watermark table. By adding a column for schema name, we can make this solution more dynamic so we're not hard coding the schema. And so we can do with other columns like the date column in case that you are sourcing from different systems, then the last modified date or the modified date could be named differently. If you find this topic interesting, please check out one of the older videos I have on this topic. It's more extensive and it's using Data Factory as a concrete example, but the concept is still valid. In the next upcoming video, I will be demonstrating how to do this in Microsoft Fabric. And again, thank you for listening and have a nice day.